Okay guys, in our last video, I introduced the concept of normal distributions. Remember, these are also referred to as bell curves. And we're just going to continue on looking at them today and examining their properties a little bit more. So it says you can make a reasonable estimates about the data that approximates a normal distribution, because data that is normally distributed has special characteristics. The properties of a normal distribution can be summarized below. So normal distributions can vary in two main ways. The mean determines the location of the center. So this is what we talked about yesterday. And remember, the mean, the mode, the median are all equal to each other. So if you're given the median instead of the mean, you put it in the same spot. Okay? So the mean locates the center of the curve on the horizontal axis, and the standard deviation determines the width and the height of the curve. So remember, the symbol for standard deviation is the circle with the little line on the top. Now remember, you do 3 ticks above the mean and 3 ticks below the mean. And to get this number here, you add standard deviations. So this point right here is referred to as the mean plus 1 standard deviation. This one is the mean plus 2 standard deviations. And this one is the mean plus 3 standard deviations. This one is the mean minus 1. This one is the mean minus 2. And this one is the mean minus 3. And hopefully all of our data values will fall between those two numbers. Okay? Now, there's another rule I want to make you familiar with. It's the 68, 95, 99.7 rule. And I know they'll sound like very weird numbers, but just give me a second here. So, because this curve is standard, remember the mean is the middle. 50% of the data lies on the bottom half, 50% lies on the top half. So here's that scale at the bottom that I was just showing you. So what we say here is 68% of the data, so 34% on this side and 34% of this side. So 68% of the data falls within 1 standard deviation of the mean. So if you go from 1 up to 1 down, so 68% of your, let's say if this, we take the class average on a test, okay? And I find the standard deviation using the methods I've shown you in other lessons. 68% of you should score between this number and this number. Okay? If we go to our next jump, so within 2 standard deviations, 95% of you. Now, where does this number come from? Okay, so if you go 95 minus 68, okay, what you will get out when you do that is 27%. And then they just divide it in half, so 13.5 here and 13.5 there. If you go 3 jumps, 99.7%. So again, if you do the same idea, so if you go 99.7 minus 95, you get out that 99.7 minus 95. You get out 4.7, and then divide it in half, you get 2.35. Now, notice it's 99.7, it's not 100%. And the reason why is because it gives you still the option to possibly have outliers. So could technically you go to 4 standard deviations? Yes, but then you're getting into like the 99.99835 kind of numbers. And so to go beyond 99.7 is, we don't need to do that. Okay? So for today, we're going to use these numbers. So when we do the assignment today, just have the notes beside you with all of these numbers on there, and you're just going to simply use them. In our next lesson, in the next video, I'm going to show you how your calculator can actually calculate out these values for you. Some special buttons you have to hit, but these numbers are actually built into the calculator. But for the purposes of today, I just want us to use this chart and use the examples that are on it. Okay, so I'm just going to scroll here until I get to the information that I want to get to. So I'm just going to scroll through some of these big examples. We don't need to do all of them. So we're going to start with this one. So it says below is a normal distribution of the weights of adult male husky dogs. And we're going to fill in the blanks. So Jim raises Siberian Husky sled dogs at his kennel. He knows from the data that he has collected over the years that the weights of the adult male dogs are normally distributed with a mean of 52.5 and a standard deviation of 2.4 pounds. Jim uses information to sketch a normal curve with 68% of the data within 1, 95% of the data within 2, and 99.7% of the data within 3. So here's the picture. So notice the 52.5 is in the middle because that is the mean. And then the way he got these numbers here is he added the standard deviation. So he went plus 2.4. So if you go 52.5 plus 2.4, you get 54.9. And then he added 2.4, added 2.4. And then he minus 2.4, minus 2.4, minus 2.4. So in other words, 99.7% of his dogs should weigh between 45.3 pounds and 59.7 pounds. Okay? So now using that information, we can answer these questions. So what percent, so these are the assignment questions now. So what percent of male huskies weigh between 50.1 pounds and 54.9? So between 50.1 and 54.9, so that is one jump. So one jump out from the mean is 68%. 95%, so that is two jumps out. So two jumps out weigh between 47.7 pounds and 57.3 pounds. Blank percent of male huskies weigh between 45.3 and 47.7. Okay, so 45.3 is right here. 47.7 is right there. So if you remember from the other page, remember this was 34, this was 13.5, and this was 2.35. So again, if you can't remember those numbers, all you have to do is just have this note sheet right beside you so that you just have all the numbers handy. So there's that 2.35. Okay? So all I have to do is just put that number there. Then it says the mean weight. So remember that is the number in the middle. So that's 52.5. Okay? So pretty simple stuff here. So it says here, the ages of members of a seniors curling club are normally distributed with a mean of 63 years and a standard deviation of 4 years. Okay, so the first thing we have to do is we always have to construct the curve. So our mean is 63, and our standard deviation is 4. So we're going to add 4 going up and minusing 4 going down. So we have 67, 71, 75, and then we have 59, 55, and 51. So again, almost all of the members of this club are between 51 and 75. And then if they had anybody out of that, then those people would be considered outliers. So the question said, what percent of the curlers is in each of the following age ranges? So 55 and 63. So 55 is right here, 63 is right here. So again, this one's 34, this one's 13.5. So we're just going to add those two numbers up, and you get out 47.5% of the members of that club are aged between 55 and 63. How about between 67 and 75? So 67 is right here, 75 is right there. So again, this one's 13.5, this one's 2.35. So 13.5 plus 2.35, so 15.85% of the people in that club are between those two ages. Now, older than 75, so that's this right here. So we haven't done one of these. So remember, from here to here is 99.7. So if I go 100% minus 99.7, I get out 0.3. Now remember though, that has to be shared equally between these two spaces. So I have to divide that by 2. So if I go 0.3 divided by 2, so that is 0.15 of a percent. So it's like 0.1 of a percent. So it's not even 1%, it's 1/10 of 1%. Okay? Of somebody will be over. So that's why they're considered an outlier. Okay? So before I go any further, where you might be thinking is, what if I asked the question, instead of 67 to 75, what if I asked between the ages of 70 and 80? So here's the problem. 70 is right about here, and 80 is right about here. Now, I would be asking what percent of curlers are within that. You can't do that right now. Could you estimate it? Yes. So you would know that this little chunk here is 2.35. And you know this little part from here on up is 0.15. And you could estimate this to be, well, this is 13.5 for the whole, so I'm going to estimate that to be about 6. So if you go 6 plus 2.35 plus 0.15, you could figure it out. But it would be an estimate. So what I'm going to show you tomorrow is how to do questions like that. When the numbers aren't lining up with our x-axis, how do we do it so that we don't have to estimate? Okay, so for today, all the questions I'm going to give you are going to line up with those numbers on the x-axis, but starting tomorrow, those numbers will not. Okay, so let's just do one more here. So it says 2 baseball teams. Just get that to shrink down here. 2 baseball teams flew to the North American Indigenous Games. The members of each team had carry-on luggage for their sports equipment. The masses of the carry-on luggage was normally distributed with the characteristics shown at the right. So the men's luggage had an average of 6.35 and with a standard deviation of 1.04. So sketch a graph to show the distribution of the masses. Okay, so I'm just going to go like this. So I'm going to label this one the men. So I'm going to go 6.35 here in the middle, do 3 ticks up, and do 3 ticks down. And then we're going to add 1.04, and we're going to minus 1.04. So again, just use your calculator so you don't have to do it in your head. So you get out 7.39, 8.43, and 9.47. Okay, and then if I do the same thing now with subtract, I get out 5.31, 4.27, and 3.23. So that's how the men's stack out. So 99.7% of the men's luggage is weighing between 3.23 kilograms and 9.47 kilograms. Now if we did the same for the women's, so the women's, you'll notice, has the exact same mean, but they have a lower standard deviation. So we're going to go 6.35 plus 0.59 is 6.94, 7.53, and 8.12. And then subtracting, I have 5.76, 5.17, and 4.58. So the women's luggage weighs anywhere between 4.58 kilograms and 8.12 kilograms, whereas the men was 3.2 to 9.47. So the women, because they have a lower standard deviation, remember standard deviation is how spread out your data is from the mean. So because their standard deviation is lower, there's less of a range in the weights of their luggage. It's more consistent. Remember, the lowest standard deviation, the more clustered your data values are around the mean, so the less range of values you have. So it says the women's team won the championship. Each member received a medal and a souvenir baseball with a combined mass of 1.18 kilograms, which they packed in their carry-on luggage. Sketch a graph that shows how the distribution of their masses of carry-on luggage change for the flight home. So all we have to do is we have to add on 1.18 to the mean. Okay. So we're going to add on 1.18, so 6.35. So the average now is 7.53. But because they all got it, everybody is adding the same 1.18 kilograms. Because everybody's adding the same 1.18 kilograms, the standard deviation does not change. So the standard deviation is we're still going to add and subtract the exact same number. We're still going to add and subtract 0.59 because I am not changing how spread out the data values are. Okay, they all did the same thing. If it was like only the captain and the co-captain, or the captain and then the assistant captain got the medals, then that would change the standard deviation because not everybody is adding the same amount. So it's causing more variety in the weights of the luggage. If that was the case, we actually couldn't do the question. We'd have to be told the new standard deviation. Okay, so when they all got the medal, that changed the mean, but because they all got it, the consistency stays the same. Okay, so if you have any questions on this assignment, don't be afraid to ask, but honestly, what you want to do is for this assignment, make sure you have this picture right beside you so that you can just literally copy the numbers down and fill in the blanks as you need to. Okay, so if you get stuck, ask, and we will see you in the next video.